Rehabilitation engineering is the use of engineering principles to solve clinically relevant problems, especially for people with long-term medical conditions. Clinical scientists working in rehabilitation engineering work across a number of areas, including assistive technology and clinical gait analysis. When walking becomes painful, it can severely reduce a person's quality of life. When people have problems with how they walk, known as their gait, it is important that treatment plans are based on scientific evidence. Walking involves bones in your legs moving relative to each other and around joints. Often, a pain at one location when walking is due to a misalignment elsewhere in this linked system. Treatment for pathological gait often involves surgery, but it is not always possible to identify the critical limitations with a person's gait just from watching them walk. Clinical gait analysis is a scientific method that gives clinicians detailed information about how people walk that would be impossible to get any other way. Markers are placed on the skin to identify anatomical landmarks such as the pelvis, the femur, the lower leg and the feet. Walking is a complex process that involves movements in many different orientations. Think about how complex your foot is. How many different ways can you move your foot around? Even the knee does not simply bend and straighten, it has movements in more than one plane. Knowledge of these joint angles, known as kinematics, combined with the forces in the joints, known as kinetics, is what the clinicians require in order to make treatment plans. When the patient walks along the walkway in the lab, the trajectories of all the markers are being recorded with the 16 infrared cameras mounted on the walls. Computer software is then used to create models of the body segments of interest. From these computer models, detailed kinematics and kinetics of a person's gait are calculated. A multidisciplinary team of surgeons, physiotherapists, orthotists, and clinical scientists then interpret all the data and make recommendations about treatment plans. Clinical scientists are involved with all stages of the gait appointment. To ensure accurate data is being recorded, it is important to calibrate the cameras and force plates. This is done to ensure they are all synchronized correctly. Clinical scientists then capture the data when the patient is in the lab, and then afterwards process it to ensure it is meaningful. The social model of disability says man-made barriers prevent a person from being able to perform tasks. The social model aims to enable people to perform tasks by using technology to either increase their own functional capabilities or reducing the functional requirements needed to perform a certain task. Clinical scientists working in assistive technology are at the interface between the medical model of disability and the social model of disability. For example, by moving the centre of gravity of the wheelchair occupant, providing a rigid and lightweight chair, and increasing the size of the wheels, a wheelchair can become a lot easier to manoeuvre. Removing cobblestones and providing drop curbs would also be an extremely effective solution. How might you control a wheelchair if you lost the use of your arms? Chin control is one method of assistive technology to raise a person's functional level. In fact, wheelchair controls can be adapted to accept very low levels of functional ability. Control of a wheelchair can be gained from a simple blink to the ability to sip and puff. Other methods to control a wheelchair requiring even less functional ability are available. It is possible to develop a system which requires almost no input from the user. At a simple go command, this wheelchair will follow a reflective line that is laid out on the floor. Some people with limited ability to move around can develop very complex postures. Sometimes these can be corrected. However, if the posture is fixed, attempts can be made to manage the posture, hopefully preventing it changing even more. There is a range of equipment available to provide support to people with complex postural shapes. These products are available off the shelf. However, when off-the-shelf solutions do not offer adequate support, a custom contoured product may be required. Special vacuum bags filled with beads are used to form a cast of the client as they sit in a corrected position. A scan is taken of the cast using a white light scanner to create a digital version of the desired shape. Computer-aided manufacture is then used to cut out a foam block to the shape of the original cast. It takes about an hour for the machine to cut out the shape of the seat. An engineer can then trim it to the required size. A mid-fit appointment is usually required to make sure the shape is correct, before an upholsterer makes a set of covers and the engineer interfaces the seating to a suitable wheelchair base. The finished product closely matches the client's shape, ensuring close contact to their posture, eliminating areas of high pressure, and resulting in a very comfortable seat for the individual. In conclusion, clinical scientists use scientific and engineering principles to solve clinically relevant problems for people with complex, chronic medical conditions. They do this by working closely with service users, clinicians from a range of backgrounds, and equipment manufacturers. By increasing functional ability and reducing functional requirements, clinical scientists are enabling people to improve their quality of life. Clinical scientists have an excellent mix of academic and practical skills that are needed to develop new procedures, to ensure best practice, and to get best outcomes for their service users.